In this video, we are going to cover equations with special cases. So far, we've learned about equations, all sorts of equations, really complicated equations. And every time they've had a solution, like x equaled or the variable equaled a number. In this lesson, you're going to learn that you're not always going to have an answer like x equals 5 or x equals -2 or even some fraction. Sometimes you may end up with no answer or infinitely many answers. Let's go ahead and get started. So each of the equations below have been left with blanks. So these blanks, imagine them as variables. Fill in the blanks with a number that will make the equation true. The number you pick for each blank must be the same in each blank of that problem. So, for example, A, what number would make this equation true? 2 times something equals -10. Well, 2 times 1? No, 2 times 1 doesn't equal 10. 2 times 5? Well, 2 times 5 is 10, but that's not the same as -10, so we're getting closer. How about 2 times -5? Does 2 times 5 equal -10? It does. So -5 would be the solution. How about B? What number can we stick in here? Now, whatever number I choose in one, I have to put in the other. Let's go with 0. Does 5 times 0, well, that's 0. 5 times 0, yeah, 5 times 0 equals 5 times 0. So yeah, 0 works. Is that the only number that would work? No, some of you may have been thinking, well, let's stick 1 in there. Does 5 equal 5? Yeah, it does. Some of you may have even been thinking, I don't know, how about 10? 5 times 10 is 50. 5 times 10 is 50. Yeah, does 50 equal 50? Yeah, pretty much you can put any number in here. Any number. Any number. And your answer should have worked. Even a decimal or a fraction. Let's go to number 3. What number can you stick in here? Now, remember, you can't just say like, oh, this is, how about 3 plus 3 and 5 plus 1? No, it doesn't work that way. You have to choose the same number for both. So, like, could I put 1 in here? Does 3 plus 1 is 4? 5 plus 1 is 6? That wouldn't work. A fraction? Maybe if I stuck a half, that's like 3 halves, and 3 plus a half is 3 and a half, and 5 plus a half is 5 and a half. So no. Is there any number we can choose? I don't think so. No number works. So, question mark. How about D? 12 plus what equals 12 plus what? We can pretty much stick any number in there, can't we? Like, let's go ahead and do 7. 12 plus 7 is 19, and if I put 7 on the other side, 12 plus 7 equals 19. So really any number. Any number is going to work. For E, something minus 2 equals something plus 2. Is there any number I can stick in there? You probably already figured it out. Like, there's nothing you can stick in there, because if I stuck 10 in there, 10 minus 2 is 8, 10 plus 2 is 12. There's no way. If I stuck in 0 in there, 0 minus 2 is -2, 0 plus 2 is +2. That's not equal, so really, question mark. And finally, F, 15 plus something equals 25. What number? Well, 15 plus 1 is 16. 15 plus 10 is 25. Yep. Is there any other number we can stick in there? No. So record your findings or anything interesting that you found in problems A through F. Yeah, I would say some answers. Some equations had one answer. Have one solution. Some have an infinite number of solutions. And some have no solutions. And what are the solutions? Well, this one only had one solution. F also had one solution. B and D both had like an infinite number of solutions. Like, you can stick any number in either of those and it would have been fine. C and E, like, there's no number that you could have stuck in there in these blanks that would have given us a solution. So those we would say have no solution. So let's go ahead and get to the vocabulary. one solution, or I guess you can also write the word one if you want. One solution. In this type of equation, only one number will work to make the equation true. Create an example of this kind of equation. How about x plus 5 equals 8? There's only one number we can stick in x that would make that true. Or you could even say, here's another example, 2x plus 3 equals x plus 5. Yeah, I know that's more complicated, but if you move the x over, get all the variables on one side, get all the constants on the other side, you'd only have one solution for x that would make this true. And in this case, I think it's 2. 2 times 2 is 4 plus 7, and 2 plus 5 is 7. Yeah. So those are examples of one solution equations. You also have no solution equations. Now, oftentimes, when you see no solution, they'll, well, we'll do it afterward. In this type of equation, there is no a number that will make the equation. How about not a number? I'm sure that's what they were wanting me to write. Not a number that will make the equation true. Create an example of this kind of an equation. This is what those equations typically look like. Well, let me give you an example. X plus 1 equals x plus 5. Because there's no number I can stick into x that would make this true. Like if I put in 0, it'd have 1 equals 5, which is not true. How about another one? 3x plus 4, or actually, I don't even add a number. 3x equals 3x plus 5. Is there any number I can stick in to x that would make this true? No. Something you may notice. Well, actually, let's do one more. Let's do it in, how about 2x minus 5 equals 2x plus 8. Also no solution. Something you may notice about these no solution equations is that you have the same number of x's on each side of the equal sign. So on the left side of the equal sign, I have 3x. On the right side of the equal sign, I also have 3x. If you look at the one below, on the left side of the equal sign, I have 2x. On the right side, I also have 2x. So that's something you may note about these no solution equations. Oftentimes when you see no solution, people denote it by saying, hey, no solution. They'll put a 0 with a big slash through it. Not just a regular 0 like this, but like slash all the way through. All right. So last kind of special case is called all real numbers, or sometimes called infinitely many solutions. In this, so sometimes it's abbreviated as ARM, ARM for all real numbers, not ARM, ARN, all real numbers, or infinitely many solution, IMS. Anyhow, in this type of equation, any number will work to make the equation true. Create an example of this. X equals x. Or how about x plus 5 equals x plus 5. Or how about y minus 2 equals y minus 2. Now, what do you notice about this kind of equation? It's both sides are exactly the same. So x on the left side, x on the right side. This one, x plus 5 on the right. This one, y minus 2 on the left, y minus 2 on the right side of the equal sign. So in this kind of equation, both sides will be exactly the same. Whereas up here, we have x's, like the same number of x's on each side, except the rest of it was not the same. So this was x plus 1, whereas this was x plus 5. This was 2x minus 5. This is 2x plus 8. This one was 3x, and this one's 3x plus 5. So there's no way to get those to be equal, whereas these are exactly the same both sides. So let's go ahead and take a look at these equations. they may have special end up with one solution, no solution, or infinitely many solutions. Let's try this one. This is 13 minus 5x equals negative 5x plus 13. Let's get all my variables on one side. So I could either add 5x to both sides, or, well, I guess I would add 5x to both sides. That's the only thing I could do. If I add 5x to both sides, guess what? They actually both cancel out. 5x plus 5x is 0. Negative 5x plus 5x is also 0. There's nothing there. Let's go ahead and bring down the 13s. And that's also positive 13. Ask yourself, is this a true statement? Does 13 equal 13? If the answer is yes, 13 equals 13, then we would say infinitely many solutions. Infinite solutions. Or you can also say IMS, infinitely many solutions, or ARN, all real numbers. Wouldn't work. All right, let's try number 2. First things first, let's distribute the left side, simplify it. 7 times 2x is 14x. 7 times negative 1 is negative 7. Let's simplify the right side by combining like terms. We have 14x, 1, and negative 8. So this is a positive 1, that's a negative 8. When you combine positive 1 with negative 8, you end up with negative 7. And 14x is just 14x. And it's positive. 14x minus 7. The other one's 14x minus 7. Both sides are exactly the same, right? Like, we could go to the next step of, subtracting 14x from both sides and finding out that, that ends up canceling. Negative 7 equals negative 7. Is that true? Yes. Infinite solutions. Number 3. We have to simplify the left side. There's a lot going on there. So distribute the 2x, and the 2 and the x. Distribute the 2 to the x. It's 2x. Distribute the 2 to the negative 6, which gets us negative 12. Bring down the 13. And then I still want to simplify further. So combine my like terms. I've got 13 is like with negative 12, and that equals positive 1. So I'm just going to write it with my x term first. 2x plus 1 equals 4x minus 7. All right, looks like a regular equation. Get my variables on one side. Do I want to subtract 2x or subtract 4x? I'm going to subtract 2x. Does it matter which one you do? Not really. You'll get the same answer. It's just that I think this one will be easier to do it this way. Or I prefer to do it this way. It's 2x. Bring down the minus 7, bring down the equal sign, the plus 1. So now get the numbers, the constants on the other side. So I need to add 8 to both sides. Add 8. Add 7. That cancels out the 7. Add 7. I was jumping ahead. That equals 8. 2x equals 8. Divide by 2. And x equals 8 divided by 2, which is 4. So x equals 4. That is a one solution problem. Let's look at number 4. 1/4 times 8. What you do is when you have a fraction, multiply by a number, multiply 1 times 8, that's 8, and then divide by the bottom number. So 1 times 8 is 8. 8 divided by 4 is 2, so 2x. Now double rainbow. 1 times 4 is 4. Divide by the bottom number, the 4. So 4 divided by 4 is 1, and it's positive because positive times positive, so 2x plus 1 equals 2x minus 4. Ooh, you can even tell from this point what kind of solution you're going to have. Let's get rid of the variables. So I'm going to subtract 2x from both sides. That cancels, and 2x minus 2x is nothing, so you end up with 1 equals negative 4. Is that a true statement? It is not. It is not a true statement, so we are going to say no solution. There it is. My no solution slash. You can also say no sol. Either one works. I personally prefer this, or I like to write that. I think it's fun. Number 5. Draw the wall down the middle. 1/2 times 6. So 1 times 6 is 6. Divided by 2 is 3x. 1/2 times 8. What's half of 8? That's 4. On the other side, I have 2x and 1x, which are like terms, so that's 3x, and then plus 4. Look at this. 3x plus 4 equals 3x plus 4. You know, those are both exactly the same on both sides. That is infinite solutions. Number 6. Combine my like terms on the left and right. I have plus 12 and minus 8. That is plus 4, I think. So we have, bring down the 4x. So 4x plus 4. Let's look at the other side. I have 2x and 2x. That's 4x. And then plus 3. Oh, look at that. We can already tell. This is 4x plus 4 and 4x plus 3. Are those exactly the same? They are not. Let's go ahead and subtract 4x from both sides just to prove the point. That ends up canceling out, equaling 0. So does that. So I bring down the 4. I bring down the 3. There's nothing I can do, so 4 does not equal 3. No solution. All right. So number 7. Anna was solving an equation, and her last line of work read 8 equals 8. What does that mean? That means infinite solutions. Whereas Tyler was solving an equation, and his last line of work read negative 12 equals 12. What does that mean? Does negative 12 equal 12? It does not. They are not equal, so that means no solution. And that's it. That's like the one new thing is like you may run into some problems with infinite solutions or no solutions. We already have been doing a lot of one solution problems like number 3. So if you ever see these infinite solutions or no solution problems, you'll know how to handle them. Remember, infinite solutions means both sides are exactly the same. No solution means, you know, you have the same number of x's on both sides, but the constants are not equal. If you end up like solving it and you end up with, you know, a number statement that's true, like 13 equals 13, or negative 7 equals negative 7, that's infinite. If you end up with a statement that's not true, such as 1 equals negative 4, or 4 equals negative 3, which is not a true statement, those are no solution. Go ahead and try some problems on your own. Good luck.